Welcome to this video, Powers of 10 and Operations on them. In this video, we define the powers of 10, the standard form of a decimal number, and how to perform mathematical calculations on numbers when the powers of 10 are involved. We will support this by relevant examples. If you like this video, please subscribe to the channel and share the content. So let's start. Calculating the powers of 10. So let's start by defining what is 10 to the power of n. When n is an integer that is larger than or equal to 2, we define 10 to the power of n as 10 multiplied by itself n number of times. And the result in this case is equal or is written as 1, and on the right side of it is a number of zeros that is equal to n, which is the number of times 10 is multiplied by itself. So let's give an example. In this case, if we have 10 to the power of 3, this is equal to 10 multiplied by itself 3 times, since n is equal to 3. And we write the result as in here, 1, and on the right side of it, 3 zeros, because here we have n is equal to 3. Now, in the case of n is equal to 0, we have 10 to the power of 0 is equal to 1. And in the case of n equals 1, we have 10 to the power of 1 is equal to 10. Another example, on this case, we take 10 to the power of n equals 6. This is equal to 10 multiplied by itself 6 times. So here we have 1, 2, 3, 4, 5, 6. And this is equal, as we have seen here, 1, and on the right side of it, number of zeros that is equal to n, which is in our case 6. So we have 1 million as an answer. So now let's move to the concept of the reciprocal of 10 to the power of n. When n is an integer that is larger than or equal to 1, we define 10, or we find that 10 raised to the power of minus n refers to the reciprocal of 10 to the power of n. So to clarify this further, we write 10 to the power of minus n equals 1 over 10 to the power of n. So here we notice that the sign here, the negative sign turns positive as we move 10 to the power of minus n to the denominator. And this is equal to 1 over, as we have seen before, 10 to the power of n, which is 10 multiplied by itself n times. And this again equals 1 over 1, and on the right side of it, number of zeros that is equal to n. So here we can write this fraction 1 over 1 and number of zeros that is equal to n as 0 point number of zeros and then 1. And the total number of zeros here must be equal to n, which is the same as the number of zeros here. So this is how can we express this fraction as a decimal. Let's take an example. 10 to the power of minus 3. So here n equals 3. This is equal to 1 over 10 to the power of 3, which is again 1 over 10 multiplied by itself 3 times, and this is equal to 1 over 1000. And then, in order to transform this into a decimal, we write 0.0001, which here, of course, as we said, the number of zeros must be equal to 3 in total. So we have here 3 zeros. As we see, we have here also 3 zeros. Let's take another example. 10 to the power of minus 5. This is equal to 1 over 10, change the sign, to the power of 5. And this in turn is equal to 1 over 10 multiplied by itself 5 times. And this again is equal to 1 over 1 and then 5 zeros. Now we express this fraction as a decimal by writing 0.0000 5 zeros, and then 1. So it will be like 0.00001. So we notice here we have 5 zeros, and here we have in total also 5 zeros. Now we move to explain the concept of the standard form of a decimal number. First of all, we remind ourselves with the definition of a decimal number. A decimal number is a number whose whole part and fractional part are separated by a decimal point. For example, 23.12 or 2.5. The digits on the right of the decimal point represent a value smaller than 1. So here we have 12 represents 12 over 100, and here it represents 5 over 10. Here we give other examples. Here we have a negative decimal number. Here we have 0.3. Now we define the standard form of a decimal number by a multiplied by 10 to the power of n, where a is a decimal number whose whole part is a digit between 1 and 9, and n is an integer. So, for example, we have this number minus 331.145. If you want to write it in the form a multiplied by 10 to the power of n, we have first to write the number a, which is a decimal number whose whole part is a digit between 1 and 9. So how do we get this number from the number we have here? We have to leave only 3 on the left side of the decimal point. For this reason, we can write minus 331.142 is equal to minus 331.145 multiplied by 10 to the power of minus 2 multiplied by 10 to the power of 2. Because what we will notice here that this multiplication will give me eventually 0, since 10 to the power of minus 2 is the same as 1 over 10 to the power of 2. And when we multiply them together, so this number will be equal to 1. It's like multiplying by 1. In this case, we have here, this part will give me, we move the decimal point twice, so we get minus 3.31145 multiplied by the power of 2. So here we are now already in the standard form, that is a multiplied by 10 to the power of n, where we have here a is equal to this decimal number whose whole part is a digit between 1 and 9, which is 3, the whole part, and n is an integer, which is here 2. So this is the standard form. Let's take an example. Write the number 2715 multiplied by 10 to the power of 9 in the standard form. So what we do here, we notice that we have to leave 2 on the left of the decimal point. So in this case, we have to multiply. We write first 2715 multiplied by 10 to the power of 9, and this is equal to 2715 multiplied by 10 to the power of 9 multiplied by, we have to move the decimal point 3 places here in order to leave only 2 after the decimal point. So we multiply by 10 to the power of minus 3. And we have also to multiply by 10 to the power of 3 because this is equal 1. So the result will be still equal to this number. And this is equal to minus 3 here, 2.715 multiplied by 10 to the power of 9 and by 10 to the power of 3. And this will give me 2.715 multiplied by 10. We will see later that a quick way to perform this calculation, where we put 10 and we sum the powers, which is 9 plus 3 equals 12. Of course, we can perform it manually, so that we multiply 10 by itself 9 times, and then we multiply by 10 multiplied by 10 multiplied by 10, which is 3 times, which is a long calculation. We can perform manually, but as we shall see, this is performed easily by adding the powers of 10. So we get 9 plus 3 equals 12. So this is the standard form. Another way or another example, write the number 0.075 multiplied by 10 to the power of minus 22 in the standard form. In this case, again, we take the given number as it is, and we see what we are going to do. Here we have to multiply by 100 or by 10 to the power of 2 in order to move the decimal point 2 levels so that only 7 will fall on the left side of the decimal point. So the first step we are going to do is to multiply by 10 to the power of 2. And in order to maintain this equality correct, we have to multiply by 10 to the power of minus 2, because as we said, those two, when multiplied by each other, will give us 1. Okay, so now what we get from here, this will give me the decimal point will move twice, so I will have 7.5 multiplied by 10 to the power of minus 22, and this is multiplied by 10 to the power of minus 2. So the answer will be 7.5 multiplied by 10. Also here, when we have negative powers, similarly, we add them as we add the positive ones to the power of 10. So it is minus 24. We will take several examples about this later. So this is the standard form of this number we had at the beginning. Now, rules for operations on the powers of 10. So if n and m are integers, we define the multiplication of 10 to the power of n multiplied by 10 to the power of m to be equal to 10 raised to the power of n plus m. In this case, we take an example, 10 to the power of 6 multiplied by 10 to the power of minus 4. So the answer will be 10 raised to the sum of the powers. In this case, 10 to the sum of 6 plus minus 4, which is 10 to the power of 2, which is 100. The reciprocal, as we have seen before, 10 to the power of minus n equals 1 over 10 to the power of n. So in this case, we take an example. Let's take first this example. 1 over 10 to the power of 3 is equal to 10 over or 10 to the power of minus 3. Another example might be the opposite. So it's 1 over 10 to the power of minus 6. This is equal 10. So here n is equal minus 6. Okay, so when we raise it up here, it will be 10 to the power of minus n, which is 10 to the power of minus 6, which is the opposite of minus 6, which is 6. Okay, so here, for example, if we had 1 over 10 to the power of minus 2, this will be equal to 10 to the power of the opposite of minus 2, which is equal to 10 to the power of 2. So now the division, 10 to the power of n over 10 to the power of m is equal to 10 to the power of n minus m. So we subtract the power in the denominator from the power of the numerator. For example, 10 to the power of 2 over 10 to the power of minus 3 is equal to 10 to the power of, we can write it like that, between brackets, better, 10 to the power of 2, which is the power at the numerator, minus 3, where minus 3 is the power of the denominator. And this is equal to 10 raised to the power of 2. The opposite of minus 3 is 3, so it's 10 to the power of 2 plus 3, which is 10 to the power of 5. We take another example. 10 to the power of minus 3 over 10 to the power of 4. So in this case, n equals minus 3 and m equals 4. So this is equal to 10 raised to the power n minus m, which is in our case minus 3 minus 4. And this is equal to 10 to the power of minus 3 minus 4, which is minus 7. The power of a power to 10. So here we have 10 raised to the power of n, and the whole is raised to the power of m. In this case, this is equal to 10 raised to the power of n multiplied by m. For example, 10 raised to the power of minus 3 and the whole is raised to the power of 2. This is equal to 10 raised to the power of n multiplied by m, which is minus 3 multiplied by 2. And this is equal to 10 to the power of minus 6. We take another example, 10 to the power of minus 2 to the power of 4. This is equal to 10 to the power of minus 2 multiplied by 4 and multiplied by m. And this is equal to 10 to the power of 8. Now, we move to calculating with numbers written in the form a multiplied by 10 to the power of n. To perform multiplication or division on numbers written in the form a multiplied by 10 to the power of n, we gather powers of 10 together and we gather the rest of numbers together. For example, we want to find the value of this expression that contains numbers of the form a multiplied to the power of 10. So we have here, for example, each one of these numbers between brackets is of the form a multiplied by 10 to the power of n. Even if we have other numbers multiplied, for example, multiplied by 4, multiplied by 5, it works the same. We gather the powers of 10 together and the rest of numbers together. So what we mean by that is that we take 7.5 from here multiplied by 4 over 5. And this is multiplied by 10 to the power of 12 multiplied by 10 to the power of minus 5 over 10 to the power of minus 7. So here, this will give me a certain value. I think it will be 30 over 5, 6. The result will be 6 here, multiplied by, we perform the calculations according to the rules we have seen on the previous slides. So here, 10 to the power of 12 multiplied by 10 to the power of minus 5 is equal to 10 to the power of 12 plus minus 5, which is 7, over 10 to the power of minus 7. And this is equal to 6 multiplied by 10 to the power of 7 minus 7, also as we have seen in the rules. And this is equal to 6 multiplied by 10 to the power of 7. Minus 7 is plus 7. So 7 plus 7, 14. So this is the answer. Now, to perform the addition or subtraction of numbers written in the form a multiplied by 10 to the power of n, we write the terms in forms that include the same power to 10. So we have this example. Here we have powers to 10, and here we have an integer, and here we have a decimal. So what we can do is that this 10 to the power of minus 12, we can write it as 10 to the power of minus 9 multiplied by 10 to the power of minus 3. So we can write 7.9 multiplied by 10 to the power of minus 9 plus 14 hundredths multiplied by 10 to the power of minus 3 by 10 to the power of minus 9. And this is equal to, here we notice that 10 to the power of minus 9 is a common factor between two added terms. So we can take it outside. So we can write 10 to the power of minus 9 multiplied by 7.9 plus 1400, or we can write it 14 multiplied by 10 to the power of 2 by 10 to the power of minus 3. And in this case, this will give me 10 to the power of minus 9 multiplied by, this is, of course, 10 to the power of 2 plus minus 3, which is minus 1. So multiplied by 7.9 plus 14 multiplied by 10 to the power of minus 1. And this is equal to 10 minus 9 multiplied by 7.9 plus 1.4, and this will give me 4 plus 13, 2 plus 7, 9, 9.3 multiplied by 10 to the power of minus 9. And if we want, we can fix it further. So now we move to putting a number between two consecutive powers of 10. So if we have a number, for example, 2,105,000 and 395, In order to put this number between two consecutive powers of 10, we start by writing the number in the standard form. For this, we need to leave only 2 on the left side of the decimal point to be created. So we need to multiply the number by 10 to the power of minus 6 and to multiply again by 10 to the power of 6. So we rewrite the number as multiplied by 10 to the power of minus 6 multiplied by 10 to the power of 6. And this will give us 2.95 multiplied by 10 to the power of 6, which is the standard form of this number. Now we notice that 2 point, the rest is smaller than 10. So we can see that this is general is smaller than 10 multiplied by 10 to the power of 6, which is equal to 10. 1 plus 6 equals 7. At the same time, 2 point, the rest is bigger than 1. So we can see that this number is bigger than 1 multiplied by 10 to the power of 6, which is 10 to the power of 6. So from here we can see that we could put the number, here is its standard form, which is the same as this number, between two consecutive powers of 10, which are 10 to the power of 6 and 10 to the power of 7. We take another example. We have this number 0.0594. We rewrite this number in the standard form by multiplying by 10 to the power of 2 and again by 10 to the power of minus 2. Since we want to move the decimal point 2 places to fall on the right of 5. So we get equal to 0.0594 multiplied by 10 to the power of 2 multiplied by 10 to the power of minus 2. And this gives us 5.94 multiplied by 10 to the power of minus 2. Now, 5.94 multiplied by 10 to the power of minus 2, as we see, is the standard form of this number. This is larger than 1 multiplied by 10 to the power of minus 2, since 5.94 is bigger than 1. And this is equal to 10 to the power of minus 2. At the same time, this is smaller than, here 5.94 is smaller than 10. So it's smaller than 10 multiplied by 10 to the power of minus 2. Now, according to the rules we have learned, this is equal to 10 to the power of 1 here, plus minus 2, which is minus 1. And as we see here also, we could put the number we have between two consecutive powers of 10, which are 10 to the power of minus 2 and 10 to the power of minus 1. Thank you for watching.